Alright, so we're going to look at a couple more examples. So on this first one, again, we are verifying the identity. Which means that, again, we're going to start with the more complicated side. So which side for this one looks like it's a little bit more complicated? The left side, I agree. So what do we want to do there?
Simplify.
How so?
You can break it down by factoring.
What do you mean by factoring?
You can use Pythagorean because you get square root of theta minus 1 instead of tangent of theta squared.
Okay, I'm okay with that. So I'm getting rid of my subtraction, because again, notice I don't have subtraction on my right side. And we're wanting to end up with a sine squared. So what might be a good strategy then if I want to end up with a sine squared?
Convert it to sine, cosine.
Yeah, so tangent squared can be rewritten as what?
Sine squared over cosine squared.
And secant can be rewritten as 1 over cosine squared. Alright, and I think a couple of us struggled a little bit with this yesterday when we had like a fraction within a fraction. So remember, those are called our complex fractions. And we can simplify those by multiplying by the reciprocal. Or you might have also heard that, remember, we keep the top fraction. We change the big fraction bar to multiplication, and we flip the denominator. So now, what happens?
Cosine reduced.
Yeah, and what are we left with?
Sine squared theta.
Which is what we wanted, because that's what we have on the other side. What questions do we have there? Alright. Let's look at one more. Okay. So again, I can only work with one side or the other, so which side does it look like I want to work with? Probably the left, yeah. I mean, because like I have a squared over here, which is a little bit more complicated, but notice that I have two different things. And again, it's going to be easier to combine stuff than it is if I start on the right hand side. I have to be like breaking things apart. Does that make sense? Okay. So we're going to start with the left side again. We have addition. Notice that I do not have addition on our right hand side, which is what we're trying to get to. So what might I want to do?
Big common denominators in that one.
Yep. Now, be careful here, because even though both of them have a sign, remember they have to have common factors, and that sign is not a factor, so we just have to multiply both of them by the other one. So I have to multiply my minus sign. And on my first one, y1 plus sign. Are we all okay with why we chose the left side and how we picked our common denominators? So then on the first one, notice that we're just multiplying by 1. So I'm going to have a 1 plus sine of alpha. Yes? And then we're adding. And then on that one, I'm just going to have a 1 minus sine of alpha all over our common denominator, which is 1 plus sine of alpha times 1 minus sine of alpha. So we've done our addition for this part of that. Okay. Now we need to do a little bit of simplifying. What can we simplify the top to?
You got the ones together.
Okay, and we get 2. Okay. And then I have sine of alpha and a minus sine of alpha. What does that give us?
0.
Zeros, which gets 2 on top. Well, that's helpful because notice I have a 2 on my other one. So we're starting to look a little bit more like what we want. Okay. But again, I need to kind of reduce or like get some stuff to go away. So we're also going to go ahead and try and simplify the bottom. So we're going to go ahead and multiply that out. Are we okay with that? Okay. Because sometimes if this were like to reduce to 1 minus sign on top, then I wouldn't multiply it out because they would be able to reduce. But since I don't have anything on top that's going to reduce, I will go ahead and multiply it out. So 1 times 1 gives us 1. Then I have a minus sine alpha plus sine alpha minus sine of alpha squared. Which doesn't look much simpler yet, but let's trust the process. So what happens to our negative and our positive sign? They add to 0, okay. And then now notice I'm left with a 1 minus sine squared. What does that look like? Yeah, so what does 1 minus sine squared equal? So I have 2 divided by a cosine squared of alpha. Which is helpful because what is 1 divided by cosine? Secant. Now I have a 2. That just means it's going to still have a 2 in front. And remember, if it's squared, that just means my secant will be squared. Which, notice now, is what we want. Yay! So like I said, with our proofs, we're still using those same identities. It's just now we kind of have a little bit of a guide. We can look at that other side to help us maybe see what it is that I'm wanting to do now instead. Questions, concerns, comments on our identities or proofs?